Hi everyone, my name is Matthew Harrowing and I'm the CEO of Intender USA. I'd like to welcome you today to our Fraxses Springbok release and this presentation that we're providing about the latest innovation that Intender are bringing you. For over 20 years, Intender has been delivering innovative solutions to help our clients drive efficiencies in supply chain, accounting, customer management, and delivering bespoke solutions. However, 5 years ago, Intender broke with conventional data frameworks and unlocked the power of distributed computing and metadata, creating Fraxses, a single end-to-end data fabric completely driven by metadata and microservices. Fraxses today is used by clients, consulting firms, and institutions globally to drive and unlock innovation in the power of their data. Uniquely, Fraxses allows an organization to create a virtual cloud across disparate, heterogeneous data and technologies, providing a single virtual and relational data lake. Fraxses allows an organization to unlock the value hidden within their data. With Intender, your AI ambitions are unlocked, your automation programs realized, and efficiency, cost control, and processes enhanced. Simply, Intender delivers a better way of getting value from your data. Now today, we're going to be going through our agenda. We will be recording these sessions, and so please keep your questions in the chat box and your Q&A till the very end. Our agenda will follow as on the screen. Firstly, we'll go through the background, then some functional overview of the new Springbok release, product overview, more detail about what is new in this release and how we can use it to transform your businesses and organizations, some cross-cloud orchestration use cases. Then we're going to go through a really nice case study that we've been working with, a great client that we've been working with lately. And then finally, we'll go through your Q&A. I would now like to hand over to our co-founder, CEO of our UK and Europe practice and product owner, Herman Fick.
Thank you, Matthew. Jaco, just next slide, please. I'm going to briefly take you through the history of us. Etienne Fourie and I founded the Intender Group just over 20 years ago, established in South Africa, outside Pretoria, for those of you who know. We've built presence in the UK initially, just north of London. We're based out of Utrecht in the Netherlands, and then the latest office is about 18 months old, is in Atlanta, Georgia, in the US, which, as Matthew said, he's CEO of. I'm not going to touch on the fabric right now on the solutions offered, because that is the rest of the presentation. We're starting to play quite big in the digital transformation game. As a matter of fact, starting with new clients now in America as well. We've done some bits in Europe and in South Africa. Where we really take people not just through the digital transformation thinking IT, it's right into financial transformation, strategy transformation. How do you gear up for going forward? The technology in our platform supported 100%, and that is a very strong bit of our, I think, value we bring to our clients as well. We are getting quite involved in data trust, right down from a American point of view, again, in the health industry. Data trust, in essence, is, and we'll have webinars around that going forward, is how do you take your data asset and make money with it? And we are talking hundreds of millions to billions on the deals that we're currently architecting with new clients of ours in that game. InsurTech, we've got a big insurance arm, specifically in South Africa, from very specific software around that. But hugely with very big names that you all know, listed in the UK as well as in South Africa, insurance companies. That is, as a matter of fact, at the moment driven by Etienne Fourie, my co-founder, as a strategy for us. FinTech, that is big. FinTech is the broad spectrum. Banks, we've got retail bank in Europe. We've just landed a big investment bank out of America, starting here in the UK as well. Finance accounting is pretty much where we started with our previous platforms we developed or did. And then bespoke configuration development, we've got a single client that runs some of our software in 14 countries in Europe, Canada, etc. And we originated from source to pay, good old tendering, quoting, portals. We still do a lot of that. You've probably now scanned the customer base. It basically covers all of that I've just mentioned there. That is the very high level package that we bring to the table. I'm going to take you now through a next slide, which is just the high level. A lot of you that's hopefully on this webinar knows what Fraxses can do. I'm going to spend 3-4 minutes on the next slide that will just touch on the high end functional points. First of all, data federation and virtualization. That's where we started with lineage and pedigree, all the nice things you would imagine. Our federation out the box, over 250 connectors from all the mainstream databases, but right down to YouTube analytics and YouTube itself and all these things that you might want. We started in early days with data pipelining and IoT. From click streaming, gambling across the world, online gambling, huge gambling companies. And then, of course, lately it's called data pipelining. External data source blending, whether those are REST APIs, anything external to your department, maybe in your company, or whatever's out there in the world, things like the NASDAQ, which is the obvious in places like America, but whatever it might be. Then the new age data warehouse, what does that mean in a nutshell? You don't have to collect all your data. We will give you the total feeling of a single data lake, an intelligent lake. That word intelligence means Fraxses understands or discovered every bit of the data relationships that you've got in the content of your data. Linking that to the next one, multi-key data relationship discovery. Fraxses got a very unique feature where we've got AI algorithms that will go and scan through your data content, and that will then give you a probability study of this Oracle field versus this streaming data in versus maybe this thing in a Cassandra column has got a 90, 100 or 80% commonality, and then you can resolve it by literally clicking, and Fraxses then understands how data is matched and makes the world obviously quite easy in that sense. Configured ETL and migration. I mean, a lot of companies, and we see a lot of our big fintech companies, they're still in the big ETL, 10, 20,000 jobs a night to be able to roll back quickly, etc. We bring a whole new concept around that, how we do in-flight ETL, as we call it. We literally can point to multiple data sources, say grab 10 or 50 fields, massage them, change them, and write them somewhere for you. So very good for migrations. Very great for taking the traditional ETL into a config metadata environment. Write-back services, a very unique point on how we do this. This has just been released. It's actually with Springbok formally now. Obviously, we've had it in a bit of a beta release as well, but full-on write-back services to databases like Oracle and SQL, etc. So basically, we cracked the way of writing back via views. And again, very, very controlled by our engine at the back. We do ship with a brand new data visualizer that is from AM charts to D3s in there, etc. So some of our clients are now adopting that for 80–90% of their visualization needs because they don't have to maybe run all the Tableau licenses or clicks or whatever. Not that those things are bad, they're awesome for top-end stuff, but maybe not. This can do probably 80% of your visualization needs. Unstructured data analytics, we've got an embedded Rosette engine in there from Basis Tech. You can go and research that. I'm not going to talk about them today. We will have joint webinars coming up with them very soon. We do some incredibly interesting Twitter analysis, news feeds around the globe, last 24 hours, 4 companies, identifying the companies, looking at what the world is talking about you, etc., or you as a company. We have started with an application configuration tool many moons ago called Devolution, and that was originated from our previous CIO, which we then took over the last 15, 16 years, and it's just been rewritten into the brand new Fraxses framework of microservices, Jaco's going to talk about the new Kubernetes, Dockerized version, etc., and so on. So that is there. We are starting to build our first market release ones with the new release. The older one we've got all around the globe running apps and that and so on. But watch the space for that, for webinars in the new year explaining how that's going to work. And I think then on the left, you probably read it, but I can't tell you how much we passionately believe in being data, being configuration driven, and a no-code strategy. Jaco and I, when he is my CTO, embarked on this journey, I didn't tell him many things as rules. I said the world will be no-code and the world will be relational, even though it might be MongoDB or columnist stores or whatever. Just let us show the world how they used to be seeing all these new texts now in different ways, etc. So that no code is a crucial part. Anyway, that's the intro from my side around our product. I'm going to hand over to Jaco now, who's the global CTO with his teams in the UK, South Africa, etc. But Jaco, over to you.
Great, thanks, Herman. Yeah, as Herman says, I'm Jaco van die Kerk, CTO of the Antenna Group. I look after the technology teams within the group, and then I'm actively involved in development and architecture of the Fraxses product or platform. What I'm going to do is I'm going to take you through a brief overview of the actual product and all the touch points as data actually flows through the platform. So if one looks at this diagram, what one has is one has got the data applications on the left-hand side. So be it for machine learning, you want to create charts, you want to move data to your data warehouse, or even just your applications. There's a standard way of actually accessing this data through JDBC and ODBC, and also through our programmable interface, our API. So we can do some more advanced stuff around maybe connecting to data entities or data in a standard way. So what we have is we've got data objects, is what the applications actually see. So this is a single data set of data that is standard and what an application can understand. So as an example, a data object could exist of multiple data entities ultimately. So what the data entities might be is it might be a connection to Facebook, to your transactional systems lying underneath, or an Excel sheet ultimately. And what it does, it takes away all the complexity around that. So the application only sees the actual single data set and doesn't have to worry about all the complexities behind it. So from a data object, one then moves to the actual Fraxses metadata engine that extrapolates all that information from the data object. So we hold what we call technical metadata, and through this technical metadata, we know precisely what the actual underlying entities are. So for instance, I know what tables to connect to, what data types there are, and any stats that we've collected around that. Those entities or that information gets sent to our query engine. And the query engine is a very advanced algorithm that we've been developing over the last 7 years. And basically what this engine does is it looks at what is the fastest way to actually get to the data. So it does things like works out what filters it can push down, calculations, joins, or aggregations ultimately. And it also, all the stats it's collected through it, it works out what is the best query plan to actually get to this data. So, and ultimately it uses these stats to adapt the query plan depending on what the situation is. So the algorithm is actually learning as data flows through this cluster. And it can actually adapt itself as it learns more to actually access data much faster. So what the query plan then does is it pushes it onto our compute cluster. And the compute cluster can be a single server to like run hundreds of thousands to million records, up to thousands of servers, so that we can spread the load if you need to like run sub-second responses, or if you need to run billions of records or petabyte of data through the system. So my queries to the different data sources parallel to the different data sources in the dialect that that actually understands. So if it's against a SQL server, it will talk SQL to it. If it needs to talk to the Excel file, it will actually generate code and generate the way to access that file. And if it's against a REST API, it will generate the JSON REST calls onto those data sources to pull that information back. And ultimately it comes back into the cluster, it merges that information, and then it pushes it back to the application that requested it. Additional to that is we've got a very advanced caching engine. So it actually stores the data in a columnar format on disk so that it can actually query information very fast and return it in sub-seconds across millions and billions of records ultimately. And you can schedule this cache for if you to pull data every second, every 5 minutes, every 24 hours, depending on how fresh you actually want your data around that. The next part is what's new to the Springbok release is the write back event that we've created. So ultimately, if you've got an application on the left-hand side and you want to write back information onto a data object, so this could be a data object that holds supplier names and addresses. It's a view that is actually extrapolated across. Again, it goes to the Fraxses metadata engine that then works out, okay, which tables do I have? What is my relationships? Is there any integrity, data types, mandatory fields that I need to look after to then push to the write back event? And the write back event is ACID compliant. So what it means is it makes sure that the data is written, and it does it in a transaction so that if anything goes wrong, comms drop, or a certain record get written but the rest doesn't, that it can roll it back and let the end application know about that. And then the last bit is what is the events config or the events engine, and it's actually everything that it underpins this the framework. It's a way for my developers, platform developers, to quickly and agilely be able to create logic within the platform. And it also gives the ability for our clients to also build their own events in the system with their own logic. So if they want to run a certain calculation that they have, or if they've got data scientists that have written prediction models for sales predictions, they can actually put it to the engine, and the engine will actually manage that and be able to flow the data through the actual event engine. Okay. So the next, I'll just take you through the Springbok release. And it's the major point of what we've released within the stack. So the previous version, we've kept all the functionality pretty much the same, but we've upgraded a lot of it, especially around the architecture and going serverless. And the architecture has been built because we need to be able to run anywhere and anything. And ultimately, that's what caused the re-architecture of the stack. So we just look at firstly, the architecture. We've got the actual events engine, and this is the heart of the whole platform. So where all the logic has been configured and so forth to be able to query instances or move data or run calculations, whatever the case may be around it. But what we've done is we've built apps on top of our stack. So how anybody else can build applications on the stack, we communicate through our API in the same manner. So what we've done is, from a configuration point of view, and the whole strategy about being no code, we went to build apps for people to visually interact with data, and it's more of your technical business user can actually get hold of data without having to go through IT. So what we have is, Herman mentioned, our business intelligence tool, so you can do dashboarding and build charts on your data, doesn't matter where it comes from. We've got data object builder, and it's a visual way of saying, well, I want data from Facebook, I want data from my internal system, I want to join that information, and I want to do some calculations around that. Just a drag and drop interface for the user. And then we've got the application configuration. So once again, that you can build enterprise applications, mobile applications, without having to write a piece of code. And it all runs on top of data objects. And as you see, any developers or external data consumers can access this information in the same way through the stack. Then we've got the Fraxses federation engine. And this is what takes care of all the the heavy lifting about accessing data. So as Herman mentioned, 250 connectors we have, all the major players out there we can connect to. And this is where all the data is merged, consolidated, and served back to the user. And then we've got the flows engine, that's a data pipelining. So this is to be able to move billions of records efficiently through the stack. So if you want to migrate maybe information from one database to a data warehouse or to the cloud, this helps with that. And then additionally, Flows also takes care of any streaming data. So any smart devices, smart meters, streaming information from Twitter, you can stream into the stack to then join with the other data. The next part is just what makes up the platform. So this is a component architecture around it. And the major part is, as we've said, is the event engine and the event coordinator. So what happens is we've got a library of microservices. And these microservices you can think of as Lego blocks, different colors, different sizes. And depending on how I build these Lego blocks, I can build anything ultimately that I want. But you can also bring in, obviously, your external microservices or services in the stack to be controlled like this. So ultimately what happens is we've got the microservices that sit there, and there's an action that has to be run that says, okay, this is the flow that has to happen through the microservices. We've got a concept of what a message bus. So you can almost think in the message bus called Kafka, but you can almost think of it as a chat channel. So what happens is each microservice listens on its own chat channel that we call topics. So if a request comes in and it says, I want to run this event, and it's got these different Lego blocks being microservices in it, each microservice will listen on their thing, and the coordinator will say, okay, request has come in, that's authenticated. I'm going to put it on the message bus, being the chat channel. The microservice will consume it, process it, and then put it back onto a Kafka channel for another microservice that's listening on that channel to actually pick it up, process it, and move on again. And the events coordinator will coordinate the flow of that transaction through the whole system. Okay. Then the next step is the low-code platform that we've built on top of the platform. So because we can master data, we know where everything comes from, it's easy now to build applications on top of it. So a whole full configuration side of building apps and enterprise apps on the system. Then we've got the compute platform where all the heavy lifting, as I said, happens with moving data, computation of data, data objects, and so forth. We've got the visualization platform called Analytics to build your dashboard, self-service BI to any data sources that you're interested in. The integration flows, once again, is to move large sets of data or to stream data into the actual platform. And then we've got a document management system. So obviously within applications, you need to be able to store documents, and we can then link those documents onto transactions within your data, and then also tag it with metadata so that you can find certain things within the documents. And then lastly, we've got the business documents, and this is your pre-printed stationery. So if you want to create PDFs for invoicing or purchase orders, printing, and your pixel perfect type reporting, that's what you can use. But under this whole platform, as you can see, we can deploy anywhere. So we can deploy it on any cloud provider or on the bare metal. And this is facilitated by using Kubernetes, because the cloud providers all have a version of Kubernetes. And this is a way to just manage applications within the cloud or on bare metal, and easy updating, scaling, and so forth. And then we don't dictate the actual storage system. So each cloud provider has got their own file systems. We support all those file systems. And if it's on bare metal, we actually ship with a distributed file system that can be used. Okay, so the next slide is just to show these are three technologies that are extremely popular, especially in the cloud environment. Firstly, Docker. And Docker, what it brings us is we can deploy microservices in a Docker image. So you can almost think of it, it's an image, and it's got all its dependencies, everything that it requires as a package within this Docker image. It helps with that what we test in development and in UAT, that it will run precisely the same as it will there in production as well. So you're getting rid of all that I need libraries or .NET libraries to be installed on the servers. Kubernetes, we can deploy Docker images onto, and what it gives us is a cluster computing, so self-healing, also for scalability purposes. So if I've got one JDBC service, I can scale it to be 10 JDBC services if Christmas hits, because I might have a lot of load there. And it will automatically scale itself depending on what the load is in the system. So it's almost like an ephemeral services where I only run it when I need it, and that helps within the cost and also controlling cost and scalability within the cloud environment. And then Harbor is a registry, so almost a library of all our microservices on the platform. And if you've got a license for the platform and you've got your Kubernetes cluster, you can assign it to go and fetch the actual platform and install it on your Kubernetes automatically. And what will happen, it will automatically install it. It will create all the network connectivity through the platform, and basically it just automatically installs it. So from a deployment perspective, it's not taking days or weeks anymore. We can actually literally get this down in an hour or two. Okay. And what also helps with this is that you have, if we have any upgrades, it's also not a whole process again to go through upgrades. It gets released to Harbor. You can say, okay, I want the newer version. So if we release a new JDBC service, the JDBC service can be pulled in. And what actually happens is that it keeps the old microservice up. It will bring the new upgraded one in, and when it's active, it will then deactivate the other service. So you are basically 100% up the whole time. Okay. So if we get to what we've developed and advanced through the actual stack, is what we call serverless microservices that I'll take you guys through. So it is actually these microservices that run as packages on its own right within a cluster and can be managed individually. A bit more explanation around the events engine and how that works, and then our smart wrapper. So if one looks at serverless microservices, so our team writes in Scala and Rust, and you can use the language required for the job you need to do or the calculation you need to do. So data scientists, they like Python and Julia, for instance, and you might have a piece of code that you've written some calculation in, and you can then reuse that and actually push it into our cluster or our platform. So what it says at the bottom, we've got connectors to data sources, but now we've created connectors for languages as well. So it really is for people, developers and people to focus on their code, but the platform to take care of everything else. So to see how that actually works through an events engine, so if a request comes through the gateway, it obviously gets authenticated. The coordinator then talks to our metadata base. And the metadata says, okay, there's an action I need to run. This is the data that comes with it. It returns it back and it says, okay, I need to run my meta service. I need to get information in there, out of there, and then I need to run it, push it to my validation service. So what happens is the coordinator talks to what we call a smart wrapper, and it's a wrapper we supply to the developer or the data scientist that wants to write the piece of code. It communicates, this wrapper knows how to communicate in that language that has been written in, processes, and then takes that data that's returned from there and pushes it back to the coordinator. The coordinator will then talk to the Rust wrapper that obviously knows how to talk with the Rust language. And then that will be processed, pushed back to the wrapper, and the coordination then can respond with the request that's coming. If we go a bit deeper into what the smart wrapper does, is we've got the component code. And this is all that the developer has to worry about. So usually a developer has to worry about, once again, libraries, how do I communicate with other functions within a system, on what servers do I have, how to run it, scalability, all that. We've taken all of that away. They really only have to focus on their component code, be that a prediction model that they've written, or they've got a special calculation that the company uses, or encryption. Just focus on that. And what the wrapper will do is it will make sure that it can communicate to the other microservices in a unified way. So we take care of the communication through Kafka, and we also take care of the security around it, so the encryption. So we use a 3-key encryption one that the client holds, the platform holds, and we hold, so that all the communication that runs through the platform is encrypted and cannot be decrypted by people that want to get into the cluster. And then lastly, we've got the logging. So anything that goes through your service, not just from a data perspective gets logged, but also what its performance is doing. So it might be under load, and you might have scale it to be more 10 of the services to actually just run more efficiently and so forth. Okay. And the next big thing is around the security of the platform. So if one thinks of big data platforms like Hadoop as just like 20 profiles, security profiles. One has to actually recreate the view for each security profile. And it's a real maintenance headache around that. So if I change the calculation in one view, I have to go and change it over the other 20 other views, depending, unless you've built it, obviously, a view on top of a view, that's also not the best way to go about it. So what we've done is you've got a data object, single point of truth, one record or one data set, and on that you can apply security policies. So data masking, so this user is allowed to see the email address, but it needs to be masked out. So this is especially for data science, you're not allowed to see the user's information, but I want to use it to actually model or predict. Row filtering is we inject security filters in there, so a user is only allowed to see data from a certain department, or is only allowed to see salaries that are lower than $100,000. And then also we've got column filtering, where he's not allowed to see the email address, or he's not allowed to see the actual salary field. And then lastly, does he actually have access to this actual data object? We've built it so it's standard, once again, for third-party applications to understand it. It's scalable, so if you've got lots of concurrent users on it, we can scale this, once again, from one server to 1,000 servers. And every microservice you can do this with. And then, obviously, very important, low overhead. So it doesn't help that you return data under a sub-second, but your security gets applied and it takes a second or two. So we've done a lot of work around that, and it actually, the overhead's about 30 milliseconds to 60 milliseconds. But the flow of data and how we do it is pretty important. So the original query comes in, so the user can request any information. He might say, well, I want to request the salary information. We read the actual rules repository and says, no, he's not allowed to see the salary field, and we actually restrict it at that level. So the data source doesn't even know, and you can't have any security leak or data leak as it comes back. It gets pushed to the source, and the source then returns the actual restricted result sets. So if one looks at maybe data lakes or other engines, they actually pull all the data and then they start filtering all that. You actually don't want the data to go over the line. You want to filter that source already. And this is what this brings for us. Then just the last bit is just to show you how our write-back service or event has been developed. So this is a multi-language one, as we developed as well. And what we had is we had our metadata service already, and we had our JDBC auditing service already, so to audit. So all we had to go and do is we went and built a validation microservice that obviously can be used anywhere else in the framework, and the execution service that also can be used everywhere else in the system. But we've went and configured this in a no-code way. And like I said, these building blocks we put together to get to some logic. So what happens is, if an event comes in, it's asked the metadata engine, please give me the details around maybe, and this example I'll show on the next slide, is I want to write information back to the supplier table and the address tables that exist behind it. The metadata service will return all the information around that to say, okay, this is the supplier table, these are the actual fields within those different tables, and it will pass it on to the validation service. And the validation service will say, okay, I've got this record that's come in, and I have to validate it. Is there mandatory fields there? I've got a phone number that's come in. Is that numeric? Is there any relationships or primary keys that I have to look at to validate that this record that's come in is valid? And if it is valid, it will then pass it on to the execution engine. And the execution engine will use the information from the metadata to then say, okay, extrapolate again, these are the entities I need to write to, or tables. It will generate the insert statements, update statement, delete statements, and then generate the actual statements or the dialect for the database that's required, and then write that information back to the database. And then lastly, we audit every record that comes through. So what was the previous value? The telephone number was this previously, and now it's this new one. So we save it into a very efficient Parquet format so that you can join it against your original data and see any history as it's moved through the actual transaction. And then the last bit is just to show really from a complex data object that's built. In this instance, it's just the supply table and 2 address tables. And it's just, you have to just write the record back to the actual event. And the event will then do the rest for you because we understand the data. We hold all the metadata around this data. So it knows, okay, I've got the supplier, I want to insert the name, the telephone number, and so forth. It knows to go in a transaction to go and insert the supplier. And when the supplier has been inserted, we'll see, okay, I've got primary keys against it. Return the primary key, in this instance being the supplier code, and then pass it on to the supplier table rights. So it will then write it to the 2 supplier tables and then say, okay, this transaction has been committed. This makes it extremely easy. You don't have to go now in the olden days, or how they still do it is you have to go to your developer. He writes it in Java, Scala. It's hard coded. It has to go through UAT and might take it like a 2-week exercise, or he has to go and write a stored procedure to do this whole multi-write to sources. So this is pretty new, and I believe the only thing within a data fabric that's been released. And that's me. So and I'll hand over then back to Matthew.
Thank you, Jaco. That was incredible. Now, as we think about some of the applications of what we can do with this, we had an exam question a short while ago, which was really regarding whether or not we could take 3 different cloud environments and bring them together as one environment and orchestrate data within those 3 environments as if they were a single environment. Now, when I started the presentation, I talked about creating a virtual cloud, or another term we've used in the past is a data fabric or data mesh now, because we have a microservice framework. So the ability to treat multi-cloud environments as a single environment is really something that's done out of the box. So the exam question was just show us how you would orchestrate multi-cloud environments. So the next slide will show you just something we stood up in an hour, which was an AWS. It was a Google Cloud, and then an on-prem solution. And we had 3 data environments in each. And within an hour, we were able to connect to all 3, analyze the schema and data in each database, and start building objects and orchestrating data between the 3 environments as if it was a single environment. And as Jaco explained, all of the security and provisioning and management is all handled within our environment. So effectively, we've created an ecosystem of these 3 environments. We treated them as one. Now, the next slide shows you the locations of these environments. So we had one in America, another in Asia, and then obviously in the UK. And it's the ability that we, regardless of geography, to be able to orchestrate and move data seamlessly between these environments. Now, the other thing I want to kind of put out there is that when we work in a multi-cloud or a multi-tech environment, it's very difficult to understand the audit trails of what data is being consumed, how, when, and where. Now, the ability of creating these microenvironments where we can scale, handle big data, but we're using them as one environment, means that I've got an audit trail that sits across my systems, regardless of where the data resides. And I'm more interested in the data objects than I am in the system that's giving me the audit log file. So rather than taking log files from each system and building them together into my tree structures, I have my audit trail seamlessly orchestrated along with my data across a multi-tech, multi-cloud environment. Now, if you think of what you can do in terms of track and trace, and then think of, as we move into more IoT, the ability to create multiple environments of hubs, data hubs, on our edge and our fringe computing frameworks, and then applying the ability to cluster and federate to other Fraxses, gives you an endlessly scalable way of managing both your data in a distributed way, but also your security and your audit trail, creating these micro environments that can orchestrate and work seamlessly with each other. Now, I'm going to hand over to Austin, and we're going to talk about a use case where we decided to apply this stack to a new type of problem.
Awesome, thanks, Matthew. So I'm Austin Pribish, the principal solution architect out here in the US, and I effectively work closely with Matthew to make sure our clients' whiteboard sessions come to life. And I'm just going to tell you, I'm going to spend a couple minutes talking about Capital Pipeline customer success story. So Capital Pipeline is a startup based out in Phoenix, Arizona, headed by Stephanie Nelson. So this arrangement was a bit of happenstance because her lead sales guy is a friend of mine from university, and I was actually just helping him with a pretty generic IT problem when he started to talk to me about what Capital Pipeline is trying to do and their current approach. So Herman and I flew out a week before quarantine, and we started analyzing the business problem. We felt that it was a great fit for Fraxses, largely because Capital Pipeline, it is at its core a database company, or rather even a database, you could say, but there's a strong backing and a huge support due to Stephanie's presence in the industry. So I'll quickly give you a little bit of background. Capital Pipeline researches, aggregates, and consults around capital improvement program data. So this data is effectively capital budget for things like roads, schools, or other public infrastructure you might have around your local town and municipality. So these municipalities release this data in semi or unstructured format. You can imagine Excels, PDFs, PNG image files, you name it. We've come across it, and so far it's so disparate and so inconsistent that even a single municipality might not release the same structured document the next year. So you have to come up with a solution that's pretty robust and can handle just about any form of data reading. So you can imagine these insights are very challenging to get at due to the disparate nature of this unstructured data. And the reason why I'm telling you this story, and the reason why we wanted to tell you this story, is it was a perfect example of a partner having that aha moment with Fraxses. So while we were out in Phoenix, and I'm kind of summarizing, but we heard the comment, you've brought my product offering and IT roadmap forward by at least 2 years. So winning this client largely came down to the ability to prototype and prototype rapidly. So if you've ever been on a business intelligence project, you've seen that there's field names are changing, new dimensions are being added to the data model. You're passing dashboards back and forth between teams. You're trying to decide on what your data model should look like. You're coming up with that central data model. And then you're also trying to figure out how to get data from its source into the underlying data model that's going to drive your business intelligence application. So we had to build this first on some rudimentary Excel spreadsheets. The general data capabilities were not all that great. This was being run on a copy and paste methodology and Excel driven with no database. And all of the classification and dimensioning that was being done on the data was also being done by hand. So you can imagine when you're sitting with a final Excel spreadsheet that's 10,000 rows deep, there's no metadata around it. We don't know what row came from what PDF. There were a lot of problems in trying to drive a dashboard with solid insights. So this was a two-part problem, and Jakob, you can go to the next slide. You can see that here's an example of one of the PDFs. On the far left side, this is something that your local municipality might release every year. It's going to have budget data, project IDs, really interesting information if you're in the contracting or procurement business. And then on the far right, you can see how those data fields map to a particular Excel document or a data table. So there was a bit of, when we got to Phoenix, we noted, we found that there was a bottleneck on their ability to basically expand past the small municipalities that they had. So we had to come up with a two-part solution, one that would solve for the bottleneck, but also one that would solve for the delivery of this data. So the original plan was to just develop some PDF reports that were kind of pre-populated with this data and then branded with the Capital Pipelines logo. So next slide, please. On the first part of the solution, on the far left side, you can see, you can kind of visualize that there's any number of municipalities in a geographical area. So what we did is we came up with a way to start organizing these PDFs in a smart way. So we came up with a zonal OCR methodology or approach, whereby we ran zonal OCR on top of the highest graded PDFs. So those were PDFs that we graded as a 3. These are PDFs that were repeatable templates year to year, 1 project per page, very clean, very nice, kind of like the one I showed earlier. All the way down to a 1, where we're going to say a 1 is going to be human reviewed. We're not interested in even attempting to do some kind of machine reading. This approach is great because now it allows our business analysts to focus solely on pointing and clicking and dragging and dropping a zone on top of a PDF. There's no OCR, I'm sorry, there's no copy and paste, there's no potential mismatch of information. So we're capturing not just the data points that we want, but we're also capturing the metadata around what page and what PDF and where in the region that this particular data point or record came from. So on point 2, you can see that they'll give us some coordinates. We'll map those coordinates to the PDF and we'll create a coordinate library. So now going forward, we know what PDF we're looking at. We know where on the PDF that record came from. We know what region that record came from, and we can finally insert that into a database, and we have the trail all the way back to if it came from Phoenix, Gilbert, Mesa counties. And lastly, the second part to the bottleneck was not just the copy and paste approach, but the classification was essentially being done by Stephanie. So we would create this Excel document and we'd have to pass it off to her, and she would essentially do some user industry knowledge to classify each individual record. So what we did is we had a meeting with her and we figured out what were the key indicators for some of this classification, and we were able to actually script those out, and we can classify to 80 or 90% accuracy right off the bat. Now, and then you can imagine now we have a pretty robust database with lots of dimensions, and it's now sitting in a really nice place for Fraxses to get a hold of. And next slide, please. So the second part of the solution was presenting it in such a way that it was better than the competition. So right now the competition is a PDF document. You get a huge book and you're thumbing through paperwork. You're thumbing through paper and projects, and you have to pretty much tote this journal around with you everywhere. So this is a much more state-of-the-art solution and approach to delivering that data than originally anticipated. So on the top left, you can see users can look by geography, by any dimension that we want to put on that dashboard, and they can start to filter projects down in the database below. And what's interesting about the database you see below, because we've tracked all of the metadata around that particular record, you can see that they can actually click into a PDF report and essentially gain access to the original raw document. So they have that raw document for their, bringing to the next meeting, if you will. And then they also have the ability to have the original branded PDF report that has the Capital Pipeline logo on it. So we really were able to make the dream of having a Capital Pipeline PDF report come to life, but we also now have a portal where users are going to be we're tracking what users are clicking on, what they're interested in. We're going to be presenting to them only projects that suggesting projects that they're interested in. So really this project is only in its infant stages, and we're going to add a lot of intelligence to the user experience to try and grab users' attentions and bring them back into the site. So I just wanted to talk about two, I think that's the last slide, Jaco, but I just wanted to talk about two components in the Springbok release that we're particularly interested in, or I'm particularly interested in. So writeback will effectively allow us to easily deploy a self-service front end that will allow Capital Pipeline direct access into their database to create, update, or delete projects as they see fit. So right now, we want to get rid of the human element of data or spreadsheets or validation or sign off, if you will, between the Capital Pipelines team and the Fraxses team. So writeback will effectively allow us to create this portal where the OCR PDFs, that data will immediately get piped into a database, and then they can go into a self-service portal. And as they're perusing this semi-structured data, now they can maintain it and publish it themselves into production. And then the second feature is the smart wrapper. So I'm particularly interested in the smart wrapper because now we can take all of these individual components that we've built out for classification and OCR, and we're going to be able to package them as their own microservice to help facilitate creating this this self-service portal where not only their clients are going to be able to come in and review the data that we've all been working on, but Stephanie and her team will be able to log into a self-service portal and start managing the underlying data themselves. And they don't need, it gets rid of the need for having a data specialist all the time working with them. So they're going to be fully self-sufficient, I'm hoping by middle of this year, which is going to be really great for their expansion. And we'll be able to focus on moving into more states and more municipalities. That's really all I've got. So I'm going to pass it back to either, probably Matthew, right, for Q&A.
Thank you, Austin. I appreciate that. And appreciate the work that was done there. And obviously we got some great feedback on that project. One of the areas that you mentioned was the fact that we brought the development window forward by several years. This is a common thing we're hearing a few times. And so really a question to you, Herman. What are some of the cost efficiencies that our clients are seeing by using Fraxses over a more traditional approaches to big data management?
Yeah, Matthew, thanks. Interesting ones. A lot in the fintech area that I can refer to, all of them referenceable. Some of the most outstanding ones that I always enjoy talking about is one of our clients that had a 5,000-hour quote from the IT division, and we did it in 18 man-hours. Thought that was quite something. I just saw an analysis that was done by a client where we on average save them 90 to 98% of time from initiation to delivery. So that is obviously huge. I mean, I know that that specific client will sit in meetings with the regulator, and the regulator is fighting about some of the numbers, don't agree with the numbers, or a different angle on that. And a Fraxses person on that call with the risk side of the bank will sit and do the change on the data object. And while they're on the call, email it out, and the regulator say, cool, that is what I was looking for. So that is obviously huge impact on number one, saving face in the fintech game, but also showing the regulator the agility of the data solution to achieve that. I mean, we can go on so many of these. It's largely, I mean, a specific bank as well, where you have a 2-man-year quote for an ETL job between Teradata and Oracle, 3 Teradata sources, Oracles, etc. And it was done by a newly trained internal Fraxses person in about 2.5 weeks. And when they asked us to audit if it was done all right, Jaco was asked to come and do the audit. He showed them how to do it in 2.5 hours. So it's really those sort of things which people can hardly believe. But this is what we find. These things are referenceable. You can call the clients. It's not a sales pitch here. So Matthew, yeah, that is the sort of things that we achieve with it.
Thank you. That sounds amazing. So Jaco, did I hear right that we now provide write-back on composite views? So can you provide some examples of where that would be important?
Well, I mean, it's it's really important around agility and getting to the no code strategy that we're after. So as I mentioned, to actually go through this process, it actually has to be hard coded by developers. It's the old traditional way of having to either go write store procedures and a developer having to actually then go and say, okay, well, this is a record that's coming in, it's a supply table, hard coded to actually write into the supply table, and then track that transaction to then retrieve the information then to pass on obviously to any related tables around that. And what this approach brings is that the technical business user or a data user can now build their own composite views or data objects, and have the ability to write back through standard protocol, industry standard protocols like JDBC and ODBC, and then also obviously REST APIs. So it's just really about the agility and being able to data that I'm looking at that I can actually immediately write back to that information as well.
Thank you. And Austin, I mean, we talked about some of the work you're doing. Now, as we think about working with more live frameworks, have you seen any examples of where we've been able to deploy machine learning in a distributed environment to perhaps support risk?
We're able to, well, first, because Fraxses is a microservice oriented framework, what we're able to do is take something that a data scientist has built, and essentially figure out, okay, we'll figure out how to do the data pipelining or the plumbing for their particular data science problem, and we can essentially package their algorithms in such a way that it's just another service spinning up spinning in the framework, and Fraxses is going to manage getting data to and from that service. And then you can even go so far as to use Fraxses to visualize the output of those data science algorithms.
Thank you. Well, we appreciate your time today. This is all we have time for. Please reach out to your local representative if you'd like to know more. If you have any questions, please email us. We appreciate your time. Have a great day, and thank you to the panelists today for supporting this presentation. Goodbye.